What happens when we create machines that are as or more intelligent than we are? What are the possible timelines, implications, and ways forward to ensure we create the most positive future for our world? In this episode's got a sequence on responding to AGI. We look at how people and organizations around the world are responding to a future with much more capable AI systems and how we can look to be more effective in our response to that technology so we can create that positive future we all want. This is the AGI show, and I'm your host, Sarush Paul. Thomas Larsen is our guest today. Thomas, who's with us here now, he's the executive director of the Center for AI Policy, a not-for-profit dedicated to developing and promoting public policy that prevents catastrophic harm from advanced AI. Thomas studied computer science and maths at the University of Michigan before going into research into technical AI safety, first as part of the Stanford Existential Risk Initiative's ML Alignment Theory program. That's better known as SERI MATS for people who know the space a bit better. And then over at the Machine Intelligence Research Institute, better known as MIRI. That's in Berkeley. So he went and did some technical AI safety research at those two places. And then the reason I asked him to come on the show today was that Thomas put together some really high quality work and published a post late last year where he did a great job looking at what all the people across the alignment ecosystem are working on when it comes to technical alignment. So getting these AI systems to do what we want and ultimately produce a positive outcome. So he did a really good overview of that whole ecosystem. And it's a long post, and I'll definitely share that post in the show links, but also wanted to get him here on the show today to walk us through that same alignment ecosystem, and to obviously give some updates on anything that's changed since late last year. So he'll be great for our listeners who are relatively new to the world of alignment, but are thinking about possibly getting involved. They can understand all the things and all the people working on this, or at least a big part of that breadth, and then go off and do further investigation as to the research areas that interest them. So without further ado, great to have you on the show, Thomas.
Yeah, thanks for having me, Sarush.
Yeah, awesome. Well, as always, I'd love to just start off with learning a little bit more about you. So, Thomas, do you want to tell us a little bit about yourself and the work that you do in AI safety?
So as you said, my background was in technical AI safety. I was sort of bouncing around between a few different agendas. So when I was at SERI MATS, I was working on sort of relatively more prosaic work. So I was thinking about goal misgeneralization and techniques for mitigating that, and wrote a few less wrong posts about how to do that. When I was at MIRI, I shifted a little more into the theoretical lens, the theoretical conceptual work, though unfortunately that work is under an NDA with MIRI and so can't be shared. And before that, actually, I was doing even more empirical ML at the University of Michigan, doing research on out-of-distribution robustness and making sure that models were correctly uncertain given out-of-distribution inputs.
Right, fantastic. So you were doing ML safety work even at Michigan.
Yeah. I got it. I've been into this, been into AGI safety for like 7 or 8 years now. I read Superintelligence like right around when it came out, and it very much spooked me. And ever since, I've been, trying to make AI go well.
Fantastic. Yeah, no, I think that book was the wake-up call for a lot of people. I know there were others, and I don't know the published dates of the other books, but yeah, that book I think came out in 2014, which is when I read it, and yeah, that was a wake-up call for me as well.
Yeah,
fantastic. Any more about your background before we kind of dig into more of the alignment ecosystem that you want to share?
Well, recently, I guess one noticeable thing is I shifted from working in technical alignment a few months ago into AI governance. So I founded a lobbying organization called the Center for AI Policy. We are basically trying to lobby the US government into passing regulation that we hope would make advanced AI development more safe, particularly focused at addressing catastrophic risk from misaligned AI systems. But still remember some of my old technical alignment stuff, and that's what I'm here to talk about.
Definitely, definitely. And I am actually curious about this. And I just want to clarify, the word lobbying has a little bit of a bad connotation, I think, in the general public. In this case, I don't think you're being funded by some big corporates trying to get something. I think you just mean you're trying to influence or like have the US government understand and put in some decent policy. Is that correct? Like, could you tell me a little
That's
bit
right.
about maybe your
Yeah.
funders or your motivations?
Yeah, we're funded by independent entities that aren't affiliated with like major AI labs. We're trying to represent the people and represent also the academic community in being a voice for safety and for hopefully just making AI go better. We're not trying to be here to like make profit or help the labs, profit off of the AI that they create. We're just trying to make sure it's done safely. So we're a common, we're working towards the common good is our mission.
Fantastic. And I remember when I went and looked at the website for your organization, I was surprised. It was like one of those first times where you look at any kind of policy organization and you just very clearly see the policy on the front page, as opposed to some relatively vague terms. So do you want to talk just a little bit about one or two of the key policies that you're hoping to see in US government?
Yeah, absolutely. So I think that the way I'm phrasing this often is I think we need visibility into advanced AI development from the government. So we need the government to sort of know how capable the most capable AI models are, and then we need breaks. We need the ability for the government to stop any AI models that are proceeding in a way that's too dangerous, where there isn't adequate safety and alignment happening. And so the way to have those, I think, is I'm advocating for a new agency within the U.S. government to be checking for how advanced the most capable models are, and to be giving licenses to those, as well as tracking hardware that's necessary to build the most advanced AI systems, so that it can know which actors in the world have the ability to potentially build a large scale AI training run.
Yeah, fantastic. Yeah, seems incredibly reasonable. So you're talking about over like simply like tracking and knowing what's happening, and in the case of a clear risk to the US and to the world more generally, being able to pause those things at that point in time. So pretty limited powers for a very significant and hopefully a risk that we don't run into, but if we do, we want to have the tools in place.
Yeah, and I mean, I guess my perspective is that it's fairly likely that we'll run into the place where we will see a significant risk, and we will not have made sufficient alignment progress in time to proceed to AGI and to superintelligence. And so I really want to make sure we have that capability in place to stop development. Yeah, but I hope I'm wrong. Of course, I hope we are able to make a ton of alignment progress in the meantime. And in that case, the safeguards won't be needed.
Fantastic. Well, I definitely am a big believer in both the importance of technical research and policy work. And I'm also a big fan of technical folks who understand policy and policy folks who understand technology. So I think it's really great that you've got that technical background, and then now you're trying to kind of see the best possible forms of legislation that's actually practicable get put in. So that's fantastic, Thomas.
Thanks. Yeah, I mean, I definitely still have a lot to learn. I think, especially on the political angle. I'm very much a newcomer to the governance space, but trying to pick up knowledge as fast as I can.
Yeah. On the last episode, we had a guest who talked about the Horizon Fellowship, which is one of these fellowships for people to get involved in policy for emerging technologies, including AI. Is that something you've looked into or would recommend people to look into?
Yeah. So yeah, what Horizon does is they place basically young people who have knowledge about technology into relevant offices within the U.S. government, and I'm quite supportive of them. I think they've done an awesome job, and they've found a really awesome cohort. The fellows that I've talked to, I think, have all been very sharp and have gone on to do a lot of work. So I'm very excited about Horizon, and yeah, very supportive of what they're doing.
Fantastic. Okay. So we'll move over now to the kind of the main part of the podcast episode, which is about that technical landscape, that research ecosystem around AI alignment. So I'll mostly hand it over to you, to start to kind of walk our audience through what does that alignment ecosystem look like.
Yeah, so when at the very highest level, I think we can bucket alignment agendas into prosaic work on alignment, which refers to work that is focused on basically aligning current day ML systems or future systems that are trained using similar ML techniques, and non-prosaic alignment, which is work that's more conceptual or is supposed to apply more generally to arbitrary AI algorithms, or just anything that's not focused on specifically, large-scale ML as the pathway to AGI development. So that's the highest level thing. I think let's start by diving into prosaic alignment, because I think that's the biggest. That encompasses the majority of what's going on right now. And I think within prosaic, the main research directions that are happening are there's scalable oversight, which refers to basically how do we oversee, how do we give correct feedback to AI models that are being trained with gradient descent? What's our signal for the gradient descent that we're doing on these models? Interpretability, how do we understand what's going on inside these massive neural networks? By default, they're just massive bundles of matrices that are pretty inscrutable. Ideally, we can scrute them. We can learn how to figure out,
we can
what mechanisms are going on.
I like scrute them. I don't know if scrute is a word, but it worked in that context.
Yeah, I don't know if it's an actual word either. It's meant to be, yeah. So interp is a big one, big bucket of a lot of work happening there. And then I think another big bucket is model evaluations. So figuring out the emergence of dangerous capabilities, when they will arrive, predicting them, and also just measuring them when they are actually there. And there's a bunch of work on out of distribution generalization and robustness. And I think one of the main ones there is the Alignment Research Center's work on heuristic arguments and mechanistic anomaly detection. So I think that's the high level of prosaic. I could now jump in to sort of go one level deeper then.
I think so. Let's jump into those and get that one layer deeper on each of them.
Okay, awesome. So let's start with scalable oversight. So scalable oversight, as I said before, it's trying to provide a feedback signal for AI models, even when those AI models start to become smarter than humans.
Right, and that's the scalable part. It's like scales above us, because today we spend a lot of time training models on tasks that we're already pretty sure we know the right answer to.
Yeah, exactly. And so the current baseline technique that's used in the current language models is reinforcement learning from human feedback, RLHF, where you basically just have a human labeler that's saying, did the model do a good job on this task or not? And so this works actually surprisingly well right now. Humans aren't perfect labelers, but we're pretty good labelers. And so we can make models appear much more aligned and also become much more performant on tasks by applying RLHF. And so the problem of scalable oversight is this will probably break down when we get to AGI, because AGIs could become more powerful than humans or smarter, better able to predict the consequences of their actions. And if that's the case, then the AI will be taking actions for reasons that the humans won't understand. And so the humans will have a hard time providing a correct feedback signal. One of the core problems here is that of deceptive alignment, where the AIs might learn to deceive the humans into thinking that the AI has done a really good job. Or that's actually not exactly quite what deceptive alignment is, but one problem here is basically just deception in general, where the AIs might learn
it might seemingly be doing something that we think looks good, but actually have another set of goals. And by the way, oftentimes when people hear these, they think we're like anthropomorphizing, but we're not talking about goals in any moralistic sense. We're just saying it has some thing it wants to optimize that's not the thing that we want to optimize, some outcome that it wants that is different to what we want.
Yeah. Yep.
Yeah. And to make that more concrete, maybe like to just give an example of something like scalable oversight. Maybe, for example, we live in a world where we have AI systems that are much better at understanding the global economy than human beings, and so it's giving us advice on which factories to build. And on the surface, the first factory might look totally sensible, but actually, it's all coming together into being something quite a bit more dangerous. Maybe it's something that ultimately creates a weapon that we don't understand, or creates a type of economic system that makes us all quite unhappy. So that's the kinds of problems we're talking about, right?
Yep. Yeah, and in particular, right, like the sort of proxies that humans would often use to give reward for an AI system like that might be, pretty different than the thing we would reflectively want. So I think, for example, if we're trying to get an AI to run a company, one thing we might use for the reward signal would be, how much money has this company made over the last few months? And of course, we don't actually terminally value making as much money as possible. But this is like a pretty easy proxy, right? This is a thing we can get a quantitative measure of. Much easier than is this contributing to the long run flourishing of humanity?
Right. We don't want the AI, for example, in that case, to break laws, destroy the environment, or kill people in the pursuit of profits. But it might not be trivial to kind of think of all of those things in advance, or predict what the system might do in advance of the situation.
Exactly. So scalable oversight's all about finding techniques that can sort of scale our oversight into taking into account all of those factors, understanding all of the things we don't want the model to do, and then understanding all the consequences of its actions that might be dangerous, and then giving it accurate feedback on top of that.
Yeah. So what are some of these methods under this category, like just as examples?
Yeah. So a baseline example is just humans giving oversight, right? In order to make that more powerful, an obvious method might be to give the humans an AI assistant. So now, instead of just a human trying to figure out the consequences of an AI action, you have a human plus an AI assistant, so a separate AI that's trying to help the humans understand, what's going on, and then give accurate feedback. Of course, one might worry about the alignment of the second AI.
I was going to say, yeah, there's a bit of some circularity there.
Yeah. So there are various ways around this. So one model is debate, where you basically structure the AIs to essentially argue with each other about what the consequences of the actions will be, and then we resolve the debate with maybe a human that's checking and seeing sort of which arguments were more convincing. And you could even maybe automate the human part of that, or have the human only actually decide a very small fraction of the debates that happen. And so the majority of them are automated, and still get pretty good performance here.
Right. This is kind of like the analogy here I feel like I like is like something like a political debate, where if you only had one person talking to you, they could maybe, given more information or knowledge or data than you, convince you of a point. But if you had two who were kind of arguing two sides of two possible policies, it's easier to see the flaws in one of them, and potentially make a better choice as the human judge in that situation.
Yep. Now, I could jump into sort of why I'm not super excited about debate as an idea, but I could also, I don't know if that's maybe going a little too deep. There's a lot to continue summarizing here.
Yeah, I think it's important to just like keep in mind for our audience that none of these things are solved, like silver bullets. Like the reason these are all research directions as opposed to, best practices is there's lots of contention as to which ones will work and won't work, and some of them people are much more pessimistic on than others.
So I think my 10-second version of skepticism for debate is that the AIs can collude with each other, and make it look like the outcome of the debate is favorable for humans, but in reality, we're getting to something that's bad. And I think it ends up being in both of the AI's interests to collude. And I think this is a pretty difficult to solve problem within the debate paradigm. So that's debate. There are a bunch of other techniques. I think another notable one is iterated distillation and amplification. And what that one is basically you have, we're saying it's quite difficult to say oversee a superintelligence with a human, right? The superintelligence is vastly smarter. It's way better than the human at predicting the future, at knowing the consequences of its actions. So it seems pretty hopeless for a human to sort of correctly oversee the superintelligence. But what if the humans only had to oversee something that was slightly smarter than humans, right? What if you could? So the iterated distillation amplification plan is sort of, let's say you have, your humans, which are IQ, 120 overseers or something, and then we're going to train just an IQ 130 AI, and then have that act in the world. And then it takes a bunch of actions. And then let's give the humans some advantages, right? Let's say we can have a lot of humans. We can have them run for a long time and think for a long time about sort of that IQ 130 agent's actions. And that is sort of the amplification idea, where we say we have a slightly dumber set of people or AIs, right? This group of 120 IQ people, and then we amplify them so that they can sort of make that jump up to being sufficiently good that they can oversee, an IQ 130 AI, and then distill that down, right? And then the actual oversight procedure is the distillation part, where they, this group of IQ 120 humans plus AIs thinking for a long time oversees the IQ 130 thing, which then gets created and can think faster than the original humans, but is still aligned, hopefully. And then the idea is you can just continue that. You can just continue doing that all the way up to arbitrarily smart agents.
So let me make sure I follow and hopefully our audience as well. So there's a system, like an AI system that you're trying to oversee. It has, by our kind of just crude measure here, IQ 130. There are humans, or a number of humans, who have slightly less capabilities, IQ 120. You amplify the humans in some way, so you give them some advantages, which might be more time, or is it also more tools, or could it be other things other than more time?
More tools or more copies of themselves.
Yeah, so maybe more of them. Yeah.
Yeah.
And then you kind of take, let's say, for example, the average of all the human decisions or something like that. That's your distillation step to like your final feedback for the AI. Is that right?
Well, the distillation step, I think, is more the whole process of training the next generation of AI systems. So the distillation step is, you use this like amplified thing to give lots of feedback to basically provide a lot of training data. And then the distillation step is training a new model on that.
Like the next iteration of the model itself. Yeah. Which includes getting the feedback, but also actually training the thing. So, So far this makes sense to me for something that's slightly smarter than us. What happens if this system is, 1,000 times or many orders of magnitude more complex than a human can comprehend? So it might be the equivalent of, today a handful of people and average people in today's society trying to make decisions about the global economy, something like where the gap is like much, much bigger. How does that work then? Or what else?
Well, so the hope would be to oversee that model with an aligned model that's slightly dumber than it.
I see.
So when you're at the 1,000 IQ models, you train it with the 990 IQ models, right?
I see. Yeah.
And then the way you make sure that this whole chain of systems is aligned is, you hope to apply some sort of induction argument where you're like, every transition, every amplify step retains alignment, and then every distill step also retains alignment. And we started with humans, which are aligned.
Right.
So hopefully at the end we still end with an aligned system.
It's kind of like if there was a company and it was like picking its successors, each generation, as long as each generation was still, handed off well, and that next generation of leadership was aligned with the company's mission or good goals, then even if it's 1,000 years on and the company has changed a lot of ways, like it's still aligned. So I see. So yeah, you're relying on the fact that it's not too lossy at each step in that process.
That's right. Yeah.
Yeah. And of course, that none of the steps just has a catastrophic issue as well, that one handover is just completely flawed.
Yep.
Yeah, interesting. Okay, well, I feel like I can see some possible. I mean, I guess we just accidentally already named some potential flaws with this one. I don't know if you want to add to that or move over to the next one.
Yeah, I think so. In my mind, one of the biggest flaws of this is like this question of like, what does it actually mean to be aligned? Where, the humans giving the feedback, we're kind of a bundle of contradictions. We don't even really know what we want. And then, so once we turn this into a super intelligence or something that's just really, really smart and is, optimizing for some fixed goal, it's kind of hard for me to even imagine what that fixed goal might be. So I think I would want some additional guarantees or some additional oversight, sort of with humans figuring out, where this is even leading to, like what values are we even, trying to align these AI systems to?
Yeah. I mean, that point that you just said is definitely a challenge with not maybe everything in the alignment space, but a huge portion of what we're doing. Any kind of learning preferences while the capabilities of these systems become much bigger, any kind of thing that seems to amplify what it means to have human preferences and the flaws that we have and the contradictions that we have as humans could be quite problematic here.
Yeah, and I think this is one of the main difficulties of alignment, in my opinion.
Yeah, and that's before you even obviously include other challenges like whose preferences and those kind of differences across people and groups as well.
Yeah. To summarize a few others, HCH, Humans Consulting HCH, recursive acronym right there, is another classic idea where you essentially simulate an infinite bureaucracy of humans thinking about what to do. There's also recursive reward modeling, which is basically recursively plugging in AI systems into the reward function for RLHF. And you can, preliminary versions of this have been done at OpenAI and Anthropic already.
Right.
Sort of considering constitutional AI.
That recursive method, does that start to look quite a lot like IDA, like iterated distillation amplification? It almost sounds like a variant of.
Yeah, I think they're quite similar. They're in a very similar family. Yeah. But yeah, I think those are sort of that's the high level overview of sort of scalable oversight and what it's trying to do. One last part of scalable oversight is, which isn't really alignment related, but I think it's necessary for safety, is control of these AI systems. So I think while you are trying to do scalable oversight, and oftentimes your goal is to basically build an AI system that can help you solve the alignment problem and scale it further. So oftentimes you don't want to just immediately rely on your solution. You want to get your AI systems to help you solve alignment. This is what the OpenAI super alignment team is doing. While you're not sure whether your systems are aligned or not, it's really, really important to have control mechanisms on them to make sure that there are adequate cybersecurity measures, there are control measures around the AI systems to make sure that they can't self-exfiltrate and escape into the world and then launch a takeover attempt or something. So I think Redwood Research has been doing a bunch of recent really good work on AI control, in basically creating ideas for how to structure AI research assistants that are able to help you with alignment, right? They're communicating with you a bunch. They're getting to run code. They're getting to, get empirical feedback from the world because that's necessary to make alignment progress. But they're hopefully not able to, hack out of the boxes that we're putting them in or manipulate and persuade humans. And I think that's a really important research agenda to sort of keep in mind and to execute on really well when we're attempting these scalable oversight techniques.
Yeah, absolutely. And I think, this is, I mean, you kind of phrased it as a bit of a temporary piece, but I think it might also be permanent. Like you almost always want to have, well, it's very hard to predict the long future, but it seems like it's a good thing for us to be able to pull levers that stop, slow, limit the impact of AI systems for a very long time, at least for the foreseeable future.
Yeah, I mean, I might push back on that a little bit. Like if we have, I think, sufficiently good alignment, I think we want sufficiently good alignment that we can just trust these AI systems to run free in the world and to have large impacts without us, relying on them being really constrained. Because an AI that's really controlled, that's really in a box, and can only interact via like a single text channel with some programmers or something, is quite limited in what it can actually do. And insofar as we want to harness the positives of AGI, if we think it's aligned, I think we might want to let it out of the box.
Yeah, and I guess another part of this is like there's a practicality piece. Depending on how many of these systems there are, how integrated they are in our lives, and how crucial they become to any kind of like life support type systems that we do. Like if we think about all the technologies we already rely on and how dependent we are on them, and things like that, it's probably also just practically going to be impossible at some point to completely turn something off. It'll be more about limiting consequences or continuing to give that feedback more than just shutting it down entirely.
Yeah.
I know that that's certainly been the conclusion of many of the people who have spent a lot of time thinking about this. They think there's some value to slowing or stopping, but I don't think most of them think of it as the ultimate solution.
Yeah, I think that's right, and I agree with that.
Yeah, no, it makes sense. I think, although if people want to challenge that or look into that, that's a research direction as well.
Yeah. So another big cluster of agendas is sort of the whole interpretability research area, where the basic hope is right now we have very little clue as to what is internally happening within these language models or just ML models in general. We have very little understanding of why they are taking the actions that they are taking. So the hope is to fix that and to develop an understanding of what is the thought process that is going on inside of these language models or inside of these AI models in general that is leading them to take the actions that they're taking. And there are a bunch of sub areas of this. There are a bunch of different research agendas, but I'll hit on a few I think especially important ones.
Yeah, absolutely.
So one I think especially important one is superposition. And Logan Smith, the person who was I think previously on this show,
episode 1, first ever episode of the show.
So he recently published some really great work, which I hope I'm not misquoting him here, but I think he said something like superposition is solved in his post about this, which is pretty exciting news. And so, what superposition is basically it's basically very related to the fact that you've got individual neurons in a neural network that are representing many features at once. So you got a complicated world that's maybe it's got cats and trucks and the Riemann hypothesis, and then you got a neuron that like fires on each of these three concepts, even though they're pretty unrelated.
Right, and features in this context is maps to kind of what you're calling a concept, like these real world realities and concepts.
Yeah. And so the superposition problem is, when we look into neural networks, we see that these neurons, they're representing all of these different features in the world. And so it makes it really hard for us to understand what the neural network is doing because all the neurons are doing all sorts of different things. So there's been recently a bunch of progress in sort of unwrapping that via this technique called dictionary learning, which essentially learns a mapping to a higher dimensional space where the features are sparser and are therefore more interpretable. And Anthropic, I think, also released a paper using this approach recently, which is a pretty exciting development.
Fantastic. So interpretability is this space of understanding what's going on in these what's today relatively black box, inscrutable neural networks, making that more easy to understand what's going on. And superposition is the problem of there's many more concepts than there are neurons, so you can't just simply look at when a neuron, and a neuron in this context, we're talking about actual parts of this network, like the actual calculations being activated. So we can't just look at those activations. So techniques like dictionary learning and others that people are working on is about understanding what a model is thinking about when you see it firing.
Yeah, exactly.
Got it.
And that was regarded as one of the core problems in interpretability. So it's good news that we have started to see some progress on this. Though, of course, there are a number of other core challenges to interpretability.
Yeah, absolutely. And it feels like interpretability is somewhat similar to the control techniques we talked about earlier, in the sense that, they're probably not going to be things that we're going to want to rely on forever. We're not going to constantly want to till the end of time, like introspect brains. You're going to want to hopefully get to the point where you can trust these systems to just be robust and have picked up human values. But for a long time, it's going to be good to be able to also double check our work by looking at the internals of these systems.
Yeah, exactly. And I think what you said of double checking our work is exactly right, as what you want to do with interpretability. I think one thing that you really don't want to do with interpretability is do some sort of training against it procedure, where you interpret some, say, malicious thought within your neural network, and you see, oh, my neural network, it's trying to take over, or it's trying to deceive me, or whatever bad thing you interpret. And then you just keep doing RLHF on that until you no longer see any bad thoughts happening. The reason that I think this is, a thing that we shouldn't do is because this obviously just teaches the neural network to stop thinking thoughts that look bad to humans in ways that our interpretability techniques can find. Right. And so unless we have like worst case interpretability, so we really understand sort of any configuration of the model,
it's like impossible for it to hide something.
Yeah. But that's a much higher bar than, regular medium case or average case interpretability.
Right.
Yeah. So it's much better as a technique that sort of validates a different alignment technique. And you can see, oh, look, my model never is thinking the bad thoughts in the first place.
Yeah, I feel like this is somewhat analogous to holdout test sets for machine learning more generally, where if you just give it your test set and put that into your training, then it will get very good at telling you the right thing on the test set. But it doesn't mean now you've like solved all of your out of distribution or like real world problems. There's a similar thing here, and it almost seems like, if you start to use interpretability as a form of evaluation, that evaluation becomes less effective.
Yeah, I think that's exactly right, and I'm really hopeful that we can develop some held out validation set effectively of sensors that can detect when AI models are sufficiently capable that we should start worrying about takeover, and also sufficiently misaligned that we should start worrying about takeover. So hopefully those can trigger because we haven't, overfitted to them when we see danger.
And I think this is a good example of a concrete example of why you want really technically capable people on the policy side too. Because let's say, for example, one day we have legislation that says you must be able to do this and this and this through interpretability, and you must not see, these kinds of concepts or beliefs in the system. But then some less scrupulous company just decides to do something like train against it, then you're not solving the danger, but you've covered up the problem. And you really want people like your regulators and policymakers to understand these kinds of tricks. So you want your regulators to actually understand the technology well enough to make sure the outcomes are going to be safe.
Absolutely. There's a bunch more work in interpretability. I think a bunch of it is under sort of this heading of scaling interpretability. So, we can do an okay job at taking a really small neural network with, thousands or even tens of thousands of parameters and sort of understanding what each of those neurons are doing. But, current cutting edge models have something like 100 billion parameters, making it a much tougher ask to understand, everything that's going on inside there. So there are a couple techniques that have been proposed for sort of how to go about scaling interpretability. An obvious one is we can punt it to the AIs. So hopefully we can have AIs, doing our interpretability work for us. And OpenAI did some work where they used GPT-4 to interpret neurons in GPT-2, and sort of just go through all of the GPT-2 neurons and ask GPT-4, what do you think this neuron is doing? Here's a bunch of data on, which examples it's firing on and whatnot, and you can get some sort of basic results there. Another technique is causal scrubbing, which is a method developed by Redwood Research that essentially aims to evaluate how good a proposed explanation of what a model is doing is. So it should basically be able to take, here's my proposed interpretability solution. Here's what I think the model is doing, and then the model, and then causal scrubbing tells you, okay, how well did my explanation actually explain the model? And what you can do with that is you can sort of, use that as a checker for how good an interpretability solution is, and then, try a whole bunch of interpretability solutions until you find one that, registers as good.
Right. So this is almost like a method for evaluating interpretability techniques.
Absolutely.
Okay.
But methods for evaluation, can easily be turned, or can at least plausibly be turned into generation techniques, because you can, get AIs to generate proposed explanations, and then now you've got a really good way of measuring and giving feedback to those AIs. Or you can, even do stuff like brute force search or whatever, though, you're going to run into some exponential problems. But.
And I guess we should highlight the obvious flaw in at least one of the things we just said, which was GPT-4 interpreting GPT-2, in the sense that obviously we're using a much bigger system to interpret a smaller system. And so if we're trying to interpret our frontier, biggest possible model that we've got, that's not going to quite work, but that's okay. I mean, these are all research directions, so none of these things are done and dusted methods. They're just things that we're trying to better learn how we can solve these problems and better understand the problem space and solution space.
Yeah, and I guess I should also add maybe a little bit of context of just interpretability is in sort of early days, and I think none of the existing interpretability techniques are yet all that useful for helping with alignment. Some people would quibble with me on that, but I think that's what the majority of people think. And so the hope is that interpretability will evolve over the next few years and then start to, lend itself to being actually useful and have techniques for alignment being built on, what we've discovered.
Yeah, and that's been what you just said is certainly my understanding of the consensus opinion as well, or the majority opinion as well.
Yeah. Yeah, so maybe one last thing I'll say is I think another notable work in interpretability was the Colin Burns activation probes, honesty probes, which I think basically was a technique for basically finding an honesty direction or a truthfulness direction in the activations of a large language model. And roughly my recollection of how this works is you take a bunch of statements and their negations, and then you see where they, you run them through the model and see, which activations you get at each layer. And then you look for a clustering, you look for a direction on which you get sort of two nice clean clusters where you have all the truthful ones, all the correct statements on one side and all the incorrect statements on the other side. And then you're like, okay, cool. Now you've got a direction where all the correct statements are on one side, all the incorrect statements are on the other side.
And are we talking here, when you say direction and clustering, are you talking about on the embedding vectors, like the embedding space vectors?
Yes.
Okay. And for those listening,
well, it might have been in the MLP layers. I forget whether it was actually in like the residual stream of a transformer or the MLP layers. I suspect it might have been in the MLP layers.
Right. So, and I think you could be right about that. I think you can put these probes in different parts of the model, but specifically by probes, I mean, we're looking at the vectors in some part of this large language model, or in this case, usually something smaller than a very large model, but some model. And and then we're doing the techniques you just described. So looking at the directions of these vectors and what clusters of directions you can look at.
Yeah. And that was a cool technique. And the hope is that you could turn this into basically a intervention that could create truthfulness by, artificially adding that direction in to activations to push them to be more truthful.
Yep. And I should probably say that I've seen also, and every single one of these methods has this, but it's definitely good to highlight that there are critiques of methods like this at the moment. Things like, well, are these real truthfulness vectors or directions, or are we seeing spurious correlations? Are we likely to find something just by things that, yeah, exactly. There's spurious correlations that don't generalize more generally to new data sets or new models, things like that.
Yep. I think the next agenda that we should discuss is heuristic arguments from ARC, the Alignment Research Center. This one I know less well, and they haven't released a whole lot about, but I think it's at least worth discussing briefly. And the basic hope here, as I understand it, is ideally we want to be able to prove properties about how safe models are. And unfortunately, finding proofs, like proving that a neural network is generalizing correctly or something, is really difficult, right? Proofs about neural networks is just a very high bar given how complicated neural networks are. And so the hope with ARC is that they can find these weaker things that are similar to proofs called heuristic arguments, but they're easier to find because they basically let you make some additional assumptions. And the assumptions are something like, by default, we can assume that two things are independent unless we have a reason to think that they're not independent. And this lets you, have a basically more easily find formal arguments that a model might be safe.
Gotcha. And is there, yeah, and you said you haven't gone as deep, and this is actually one area I don't remember much from myself. So do you know how much, maybe any key outcomes of this research, or if people consider it to be kind of promising and are continuing work on it?
Yeah, I mean, so my understanding is this is what the Alignment Research Center and Paul Cristiano have been focused on full time for like the last year and a half or something. And it's, yeah, I think many people are skeptical. I'm a bit skeptical, to be honest, though I don't fully understand it, and so you shouldn't really trust my skepticism. I think from my perspective, one of the key problems is, what are you even proving? So what is the formal statement for which you can prove that successfully implies that your model is actually safe and won't be existentially dangerous? And they've got great answers to this question, or at least starts to answers of this question and how they go about it. But I think that's one of the core problems, at least.
Have they published a lot on this in this area, or has it been something that's like pre-publishing?
Yeah, so they published a paper called "Formalizing the Presumption of Independence," which got into basically what I'm saying of these heuristic arguments. And that was basically a math paper, right? It just sort of explained this alternate notion of proof and formalized it. In terms of using that to help with alignment, I'm not familiar with anything. I don't think I've read anything that they've put out, but they may have. I may have just missed it. So next agenda is model evaluations. And this is one I'm particularly interested in right now because I'm thinking a lot about how to govern AI systems.
You and me both, because I'm also doing research in this area.
Oh, awesome. So, I mean, the key idea with evaluations is, can we figure out how capable a model is? Is it good at various tasks which could potentially be dangerous? And so specific tasks that people have done evaluations for are, I think Anthropic recently released something about how they've been evaluating models for ability to create dangerous bioweapons. And they started to see, I think preliminary warning signs of that capability. But they at least now have a sort of preliminary warning system in place where they can evaluate all their future models for that capability. Another one is the Alignment Research Center, again, was working on an autonomous replication evaluation. So whether an AI model can autonomously replicate in the wild, so set itself up on servers, pay its own server costs, do whatever administrative hassle there is to get new AWS instances.
This is like almost one of those the most obvious thing to do, but that seems to at least show usefulness. Like the early work seems useful, which is simply, we always evaluate models for some outcomes, and now we're saying, well, pick the things that are safety relevant. We shouldn't have models out there that can be used to produce bioagents, or we shouldn't have models out there that we know for a fact seek or are able to copy themselves and spread themselves on the internet. So let's check for those exact things. Maybe it is worth talking to some of the criticisms of this area, because it's like the benefits are somewhat obvious. Maybe we should talk about some of the common critiques.
Yeah. So one main problem is it's hard to make a good evaluation, particularly because it's hard to elicit all of the model's capabilities. So what I mean by this is the way you evaluate a model, is a language model at least, is you basically just prompt it, and you say, something like, well, what's 3 plus 7? And then it gives you sample from it and it gives you an answer. And then, it maybe says 10, or maybe it doesn't. And it might have the capability to correctly answer your question without actually showing it. For example, if you say just naively prompt it, like how I was saying, you say, what's 3 plus 7? Maybe it gets it wrong. But then if someone else later says, what's 3 plus 7? Let's think step by step. And then a chain of thoughts, then it's, more capable and is better able to answer that question.
Right. And this particular example that Thomas just shared, this was is a great example, because they actually showed some quite significant jump in general capabilities for these large language models. I forget the exact stats, but it was something like on some test set, it might have had 30% correctness or 30% accuracy, went to something like 60%. So a very large jump, that if we were then instead talking about the ability to make bioweapons or something much more dangerous, you would have really wish you had caught that capability early on in your deployment and release of the model.
Yep. Yeah. So it's really hard to have good audits of these models and good model evaluations, but having some, that's our best guess, in my opinion, is just much, much better than having none. I think just the key thing to note is, just because your evaluations aren't yet telling you that it can do something dangerous doesn't mean that it actually can't do that thing, right? It might well be able to, and you just don't know it yet.
Yes. And I think another criticism of evaluations is around deception. Do you want to touch on that a little bit, Thomas?
Yeah, sure. So another reason another criticism people have of model evaluations is basically that the model could be deceptive toward the evaluation. So it could, reason correctly, hey, I'm, getting all these prompts about how to build a bioweapon. Probably I'm in a dangerous capability evaluation, and they won't deploy me if I correctly, tell them how to build a bioweapon. So I'm just going to say some nonsense, or I don't know, or whatever. And then, pass. And then, the evaluation will say, oh, this model's too dumb. It doesn't know how to do anything dangerous. And then once it's deployed in the real world, it can operate with its full capabilities.
Yep, absolutely. And this is why a lot of the focus of the research field is on deception, because it makes other methods less effective. And even in the evaluations field, there are people working on things like situational awareness. Can the model figure out that it's in the training and evaluation phase rather than in the real world, because that could be relevant information in terms of how it operates in that evaluation context.
Yeah. It's also important to note, this is another thing you should do definitely if you're doing evaluations. You should be fine tuning on those evaluations, because this makes it a lot harder to be deceptively aligned, probably, because, well, if you're being trained on IID data, you would then need to basically gradient hack.
So ID in that context, you mean in distribution?
Identically and independently.
Okay, I didn't. It was IID. Okay, yep.
Yeah, sorry. Yeah, I don't think I enunciated quite right.
That's okay. I was just double checking.
Yeah, if you're training, basically, if you're training with like supervised learning data that you're just randomly shuffling around, on your evaluation, your model then, if it's trying to sandbag its capabilities here, it would have to gradient hack pretty hard. It would have to figure out ways to act such that it's both not capable and the gradients that it will receive won't nudge it to become more capable at the task. And that's a tougher place for the model to be. It's kind of brutal it's probably quite hard for the model to correctly gradient hack in that setting.
Yep. Yeah, and look, it should be said that a lot of this stuff is still very early days. Even these kind of methods and concepts we're talking about here, there's active discussion, debate, experimentation happening. So a lot of what Thomas is talking about is absolutely a concern, but people are still playing around with what it actually means and how true it is.
Yeah. But I'm all in all, like, I think I'm quite optimistic about evaluations being developed, and I think that it's a great place to go if you're interested in joining the alignment field and doing really impactful work here.
Totally. I'll maybe just touch on one more common critique that I hear and have heard of evaluation, and probably give the rebuttal of it myself, which is people do talk about, well, can't evaluations also cause certain capabilities to exist, dangerous capabilities to exist? So, for example, if Arc Evals is playing with autonomous replication, couldn't it cause that model to then start to autonomously replicate and start to do bad things in the world? And it's a valid critique. However, if most of the work of people like Arc Evals is fairly limited in terms of how far it's pushing the model beyond its current capabilities, then it's almost certainly that it's better to see and catch those things happening in the context of a security team working with that model and observing it, than for it to happen once it's already been deployed by a possibly malicious actor, or at least a naive actor out in the world. So I think if we're really that close to something like trying to break free or something, I'd still much rather see that happen in the hands of the pre-deployment, in the hands of red teamers, than in the wild, in the public sphere.
Yep, I strongly agree. So that was model evaluations. I think the next thing we should jump into is agent foundations, which is or non-prosaic alignment, which I guess is maybe the super category. And yeah, non-prosaic alignment is, it's sort of a disparate collection of things. But it sort of entails, there's just a whole bunch of work that's not specifically focused on ML systems. A lot of it was done, before the current LLM revolution, before, everyone thought, LLMs are definitely the path to AGI, or, at least put substantial.
Yeah, because I guess when people say prosaic, they usually mean LLMs and transformers and neural nets, because that's the current leading candidate for something like AGI.
Yeah.
So now we're talking about the everything else, or the methods that don't depend on AGI necessarily being an LLM to be effective.
Yeah. So, and I think the biggest actor here who's historically done the most work in the non-prosaic setting has been MIRI, the Machine Intelligence Research Institute, where I worked earlier this year. And Yeah, and Miri's agenda has been agent foundations mainly, and how I would define agent foundations is basically trying to tackle our key confusions about how advanced agents reason and work internally, so that we can then come up with productive alignment paradigms in the future once we've resolved those key confusions. One of the main problems here is, well, we, in our 10 or 20 years of work on agent foundations, we haven't actually made a whole lot of progress on resolving these key confusions, and we still sort of have them. And I could talk a little bit about what I see those key confusions as being, and I can also talk a little bit about what are the currently alive research directions that are hoping to tackle them.
Yeah, let's talk a little bit about just an example, like at least some of the confusions, because I think that'll make it more concrete.
Yeah. So one example, one way that people have discussed of thinking about a powerful AI system is AIXI or IXI. Are you familiar with that? Perhaps I should give it.
I'm a little bit familiar because I believe it was developed. The leader of that was Marcus Hutter, who used to be at the Australian National University, ANU, and whose student, David Quarrell, is a good friend of mine. So I know bits and pieces, but definitely good to kind of talk through it again.
Yeah. So IXI is basically a way of building AGI with a hypercomputer. And what it does is it basically takes the program that outputs the maximum reward, conditional on all your observations. Or, sorry, that's not quite the right way of describing it. You could think of it as basically doing ideal Bayesian reasoning over all possible programs that could be predicting the world and the observations that it's receiving, and then also picking the action that maximizes its reward, given its Bayesian distribution over models of the world.
And what is a hypercomputer?
And a hypercomputer is a theoretical object that can't exist in reality that can run uncomputable programs.
Uncomputable in the sense that it would take too long, or something else?
A slightly stronger sense than that. Uncomputable is a theoretical CS concept of a program that basically can't be run on a Turing machine. So think like the halting problem, if you're familiar, where it's formally proven to be uncomputable to basically predict whether a given program will halt or not. And the reason for this is roughly something like it would require running the whole program or running all of the programs, which is not something you can do.
Yep. So IXI is, and there's obviously a lot more depth to this concept, but it is some hypothetical, like theoretical concept of something that's, and I guess maybe bringing it back to the relevance to the agent foundations piece.
Yeah. And so I was highlighting IXI as a way to sort of pump out some confusions about agency, where we have this idealized agent, right? We sort of have this idealized agent design where it's doing perfect Bayesian reasoning. And it's sort of our closest model to like a perfect agent. But when you look a little closer, a bunch of really severe problems jump out at you. And the severe problems are, one, IXI only works in the sense where it's outside of the universe. It cannot model itself at all. It can only model sort of the rest of the universe that's happening outside of itself. And this results in problems when you, say, have multiple agents in the world, right? You can't ever have multiple IXIs because they would have to, model an IXI itself, which it can't do.
Right. Well, even before you have multiple, even when you have one, you're part of that world and are affecting it. So you do need to model yourself in that world somewhat.
Exactly. So there's a classic problem with IXI, which is the anvil problem, which is that, an ICSI program, even though it's doing ideal Bayesian reasoning and maximize reward, it might just drop an anvil on its own head because it cannot model itself. And the fact that if it were to drop an anvil on its own head, it would stop working.
Right. Okay.
Which is a pretty bad place to be. You'd think we should be able to design an idealized agent that doesn't do that.
But this ICSI discussion is a good taste of the types of theoretical concepts and thought experiments people are working on as a way to better understand the nature of intelligence, the nature of agency, the nature of affecting the world through that agency. Is that right?
Yeah.
Got it. And so what are the other types of work that people are doing in this area of research?
Yeah, so that was like sort of embeddedness as a thing, which is a big area of work that Maria's worked on. Another big area of work is stuff on abstractions. So trying to understand sort of in real life, we use, when humans do reasoning, we use these high level abstractions to reason about the world. I have a mouse and I'm like, this is an object. I reason about this mouse, and I don't reason about like each tiny quark or atom that makes up this mouse, right?
Even though there's obviously like a continuous series of atoms coming out of the mouse into the air around it, you still think of it as one object.
Yeah, and that's just like an efficient way of processing the world. But ICSI, our idealized agent model, which is the only idealized agent model we have, doesn't do this. All it does is sort of model the world at an atomic level or below, at the lowest level possible, that just perfectly predicts all the observations and then tells you that. So can we build some sort of model of the world that operates at a higher level and maybe doesn't perfectly predict the world, right? Like when I model the world as being a series of objects, I'm not making perfect, the perfect correct, like quantum, prediction about where each particle will be. But I'm like, in some sense, the reasoning that I'm doing is binding to reality, right? When I'm thinking about the world in terms of these abstractions, this does directly correspond to reality and does give me substantial predictive power on the future. So my frame on abstractions is sort of how do we understand the correspondence between the world and the abstractions that we have, and how do we build sort of a formal model of abstractions that permits this type of correspondence.
And it might be good just to, one, I think obviously we could go very deep on just this question of abstractions alone, so we won't go too deep, but also it might be a good point to I think one of the critiques or confusions about agent foundations is the theory of change. I think others like Intrepretability or evaluations and even Scalable, I mean, I think all the other ones, like it's a little bit more obvious to the average person how they get us to a solution, how they get us to a better world. Could you describe a little bit of how agent foundations might improve the world, or at least what the proponents of it would say?
Yeah, so this is a really good question, and I think it's really important. So let's talk about it. The main theory of agent foundations, as I see it, though other people have different theories of change, is we want to build a idealized agent that has some nice properties associated with it, where the nice properties are something like we understand what it's pointed at, we understand what the algorithm that it is running is doing, and we have like strong arguments for why it won't get off track. I think that inner alignment is a big problem in the current ML paradigm, right? This fact that when you select, and maybe I won't go into it, but basically the very high level is, when you select a model for some criteria, the goal that the model ends up having can be extremely different than the criteria for which it's selected for.
Right. Like, so it can have these kind of like, it's a hard one to describe, but it could have like goals that are actually not what you thought it was going to do, something where it's like, it has some outer goal. Oh, yeah, you're right. This is definitely something we don't want to go too deep into here. But the point is there are situations where it may want some things that you didn't think it wanted.
Yeah. And I think that this is kind of an inescapable problem with deep learning. and I don't really see the way around it with deep learning, and so I think we sort of need eventually another paradigm, another way of building AI systems that we know what they're pointed at and that will be stable under reflection and things like that. Right? They're not going to change around. They're going to be stable. They're going to be pointed at the thing we wanted. And an algorithm that's like this is, let's say a star search, right? A star search is an AI algorithm where we really understand what it's pointed at, right? It's pointed at the goal that you plug into the A star search algorithm that has a heuristic for traversing the tree to get to that goal. And we can make a strong argument there. Of course, A star, it's not an AGI.
Right.
The
problem is the most capable systems we have are these more black box, hard to understand systems.
Yeah. And that's I think key point against agent foundations is that whatever these people come up with probably won't ever be performance competitive with deep learning.
Well, ever's a very big word, but it's a bigger jump, right? Like it's easier to imagine we take what's already very powerful and tweak it and make it safe than it is to imagine what's this whole other paradigm that we just can't even point to that is both as capable and safer than the current state of the art LMs. But and I guess Agent Foundations does also capture a lot of things. Some of it is about understanding the nature of agency intelligence. Others, it's actually more explicit alternative models of model architectures. Would that be fair to say?
Yeah, I think that's right. And I think most people in the Agent Foundations community are sort of at the earlier stage where they're grappling with these fundamental uncertainties, which they think will later allow them to build principled agents that we know how to direct and we know we can make them aligned.
And I guess one example of a research agenda that I think is more directly aimed at coming up with one of these architectures, and I think that some people are excited by, is Davidad's research agenda. Do you know his first name, or is that his first name?
I think his name is David A. Derryimple.
Oh, right. Davidad is like his internet name or something.
Yeah, something like
got
that.
Got it. I really should look up his full name, but we'll definitely put a link to his website in the show links. Do you want to talk a little bit about that, just because that's a concrete example of something more explicitly pointing at a new model architecture?
Yeah. So Davidad's proposal is pretty complicated and I don't fully understand it. But the part that I'll give the summary that I do understand. The summary that I do understand is we're going to build a gigantic multi-level world model. And what a multi-level world model is it's sort of doing a thing which is similar to what I described earlier with abstractions, where you have some higher levels in your world model that operate on some things like cars and trains and buses, and then some lower levels that operate on things like wheels and axles and steering wheels and whatever. And then, deeper, you keep going down, you go into, atoms, or molecules, then maybe atoms, then maybe quarks, then maybe, quantum fields. My physics down when you get that level is a little hazy, but, something like that. And then you have correspondences all the way through, right? Where you're like, these atoms are the ones that, correspond to this object. And the higher levels allow for efficient reasoning. The lower levels allow for more correct reasoning. But you basically, essentially, you build this giant model of physical dynamics that models the world. And then you try to create some formal specification of what safety would look like, of what good actions, of like some goal state maybe that you want, and some safety constraints that you want, right? You want your model to, tell you how to do something. You need it to be smart, right? You want it to help you, let's say, cure cancer, or do human brain uploading or something. But then you also don't want it to like take over the world. So you have to figure out some way of expressing that in the multi-level world model. Those high level things, and which you maybe do at the high levels of abstraction, which you understand. And then you have some algorithm that finds actions that you can do in order to cause the good thing to happen, that formally satisfy some constraint. So you try to find a proof that if you do this action, it will you run it through the multi-level world model, and then it will achieve these consequences within these safety constraints. So you're doing some sort of search for some proof here.
And I'd love to understand, and I'm definitely I've only very surface level skimmed little bits and pieces around Davidad's research agenda. So this is my own kind of lack of knowledge, naivete. But how does this different to, say, for example, the symbolic AI type efforts that preceded the deep learning revolution, where we tried to have much more explicit understanding of the concepts in the world and tried to build that up. And from what I understand, the success of those efforts were fairly limited in terms of capabilities. Is this fundamentally very different to that? Or more generally, how does this research agenda think about the hard problem of learning about the world and navigating it?
Yeah, so I think this paradigm it's trying to use deep learning and to actually achieve a lot of the components that we're talking about.
Okay.
And so I think a lot of the components of the multi-level world model might end up being learned. A lot of the transition dynamics of the world might be learned with deep learning, and a lot of the proof finding might be learned. And so this, I think, helps with.
So it's still using the learning algorithms, just within a different framework that allows these concepts to be explicitly named and worked with.
I believe that's the hope. I think one of the as you maybe mentioned, the fundamental problem of symbolic logic is you've got this token that's suggestively named, this is a car or whatever. You've got your car token, and then you've got your has token, and you've got your four wheels token or whatever, right? And there's no binding to reality here, right? There's no way of this model to do reasoning to figure out how car internals work and connect it with how engines work and whatnot. The hope is that if you have a multi-level world model where everything is correctly connected, right? There's the model's ability to understand the laws of thermodynamics and how engines work is intimately connected with its model of how cars work, and the fact that cars actually drive.
Yeah, so I guess from my understanding, and my understanding is mostly from just our discussion here today, this resembles what I've seen a couple other people, not just Davidad, working on, where they're trying to combine this more explicit world, whether it be through symbolic AI methods or others, with learning algorithms as a way to bootstrap and make them actually able to understand these concepts as perceived in the world. So some sort of happy marriage of learning algorithms and something more explicitly explainable, explicitly interpretable, and potentially controllable as well.
Yep, I think that's right.
Fascinating. Well, we've covered a lot of ground, and this has been fantastic, and I've been learning a lot, and I'm sure our audience will too. I know there's now, I think we've covered all the major areas, and I think we've got the long tail of things that maybe don't as neatly fit into that taxonomy of research agendas, and also there's just a lot more out there which people will categorize differently. Do you want to, Thomas, do a fast round, or we just talk about these other ones as a way to say, hey, there's a lot more out there beyond what we've covered?
Sure. So I'll just give maybe 10 seconds or so on each of these, or 30 seconds on each of these.
Sounds good.
But so one other is sort of this model splintering approach, where the idea is, I think Aligned AI has been working on this with Stuart Armstrong, of finding every model that corresponds to all of the out of distribution generalizations that you could possibly have of your in distribution training set, and then being conservative from among all of those extrapolations, or having some other way of selecting which extrapolation you get as a way of dealing with distribution shift problems and inner alignment. All right, so another one is out of distribution detection, which is basically this larger field, largely academic field, of figuring out when do you get an input that is very different than your training inputs. And an initial baseline method that was proposed by, I think, Dan Hendricks, is to basically look at what the output probabilities are and see if it's far from the normal output probabilities that you got in your training.
Yeah, I guess there'll of course be other ways of doing that sort of outer distribution detection. But the point is, when you figure out that when the model figures out that it's somewhere where it's never seen in its training data, maybe do something different, maybe stop, maybe ask for help, do something where you don't just start to do really wacky things that you were never trained to do.
Yeah. Next one is low impact measures. So if there's, and the goal here is basically, can you find some way to formalize the notion of not having a giant impact on the world? This might help prevent AI systems from accidentally, having gigantic impacts on the world as humans see them, like taking over.
Yep, and this might be the good touch point here. Might be like we often hear the whole paperclip maximizer. So this would be the sort of check in the system that says, yeah, try and optimize things in the context of this factory, but don't start to turn the whole world into paperclips. That would be a good way of limiting its impact. And we talked a little bit about this with Professor Richard Daisley a couple of episodes back. So it might be a good listen there if you're interested in that world.
Okay, so next one is sort of this broad bucket of threat modeling. So I think some work, this is a very broad category. And the broad category is basically, can we figure out what the threats are in more concrete terms? And I think some good work here has been done by a group, David Kruger's group at Cambridge. They wrote a paper called Goal Misgeneralization, sort of analyzing inner alignment and distribution shift problems in ML systems.
Yep. And this actually has a pretty strong connection, I think, with the world of evaluations as well, because often the threats you identify are the exact things that you're going to want to see and catch in your evaluation mechanisms as well.
Absolutely. Okay, so another work is sort of scaling laws and predicting when capabilities might advance in the future. So I think ArcEvals is often trying to do this, where they're trying to not just evaluate where models are and how capable they are, but also predict, what can the next generation do, so that we can, stop before we build something that's too powerful for us to control.
Yeah, and a good a resource to go look at here is Ethan Perez and et al.'s look into the inverse scaling laws, where they kind of looked at how as models scaled, they got worse at certain things. So that would be trying to extrapolate certain trends is a useful thing to understand, where if those things that are getting worse are safety critical or otherwise important for us to know about.
Yeah. Okay, and then another one is brain-like AI safety. And I think this is also kind of like shard theory, even though I think that people are, have a little bit of different opinions. But roughly this is, let's take the example of, general intelligence we already have, which is human brains, and try to understand what are the properties, what are the design factors about human brains that lead us to be nice and aligned. And, supposing that we could build AI systems in similar ways, could we carry over that alignment by using similar design principles?
Yeah, makes sense. And especially, obviously, given the context we're talking about is not just alignment broadly, but alignment with humans, trying to better understand human preferences and how our brain works could hold the secrets to how we get these systems to be more like us or care about what we care about.
Yeah.
Awesome.
All right, so next up is inverse reinforcement learning. And what this is basically a way of figuring out what human preferences are from human behavioral data. So the standard reinforcement learning problem is, given a reward function, so given a measure of how good you're doing, tell me what actions to do. Inverse reinforcement learning is given actions, say made by humans, tell me what values those actions were made in optimization towards.
Yeah. Would you say, this one's an interesting one, would you say imitation learning is a subcategory or a related area of work to this?
I think it's related. I mean, as I understand, imitation learning is largely, given given some human, like let's say driver motions or something, right? Can we train a policy that imitates
Like
the human
copies
policy?
that. Yeah.
Yeah, which is a little different than figuring out the values
Right.
that policy was trying to optimize for in the first place, but could be used in similar ways potentially.
Understood. That's actually a helpful way to think about the distinction there.
Cool. So then there's also been a bunch of work done on what's called cooperative AI. And a lot of what this is thinking about sort of game theoretic dynamics in multi-agent settings. So where you have multiple AI systems that are, let's say, competing for resources or trying to each achieve their goals. Can we figure out design algorithms that reach cooperative solutions where all the agents are better off instead of, say, falling into bad equilibria, like having everyone be defecting in the prisoner's dilemma that results in everyone having a worse time.
Right. And I guess more explicitly, we're talking about things like conflict between agents or, people, competitive dynamics that get us to a really bad outcome or things like that in terms of a future world with really capable systems.
Yeah.
It's almost like diplomacy and government in the context of now we have AIs than just humans, something like that.
Something like that, yeah.
Yeah, but there's something like that is probably key here. There's probably a lot more detail that there's in that field.
Yeah, but I think the Center for Long-Term Risk, CLR, has done a bunch of quite good work here, as has the Cooperative AI Foundation.
Right. It feels like this stuff is almost like the second stage or later phase in the story. Like we're most of this episode and most of the researchers are worried about how do we get the first really capable system to like not hurt us or to do what we want. This is now, okay, maybe you've got one or two or many, maybe millions or billions of these systems. How do we make sure that's set up where it becomes more of like a system or a society of AIs? That world is also safe and positive.
Yeah. And I guess for what it's worth, this is a slight tangent, but I'm relatively optimistic about the second problem. I think that sort of my best guess is once we have sufficiently capable systems that are aligned, we will, they'll be good at solving these game theory problems and arriving at cooperative solutions. And so I do see the main problem as creating, one aligned AGI. And I think that's the majority of the problem. Not to say this isn't important, though. I do think this is an important area of research, and I do quite like it.
If you could just give like maybe a 1-minute version of that, why do you think the second stage is likely to be less problematic?
Yeah, I mean, so the basic argument is just if you have capable agents, if you have agents who are really, really smart, you would just expect them to find the cooperative equilibria because it in fact gives them more reward or more utility by their own values. Like just by default of like, that's kind of what it means to be smart, is it's like really, really good at finding the actions or like finding the mechanisms that can create it, that can let it get lots of value in the world. And so like a priori, we should be pretty surprised if we, end up having smart agents that just consistently shoot each other in the foot or shoot themselves in the foot. The other reason to think is like, the counter argument to that is something like humans get into bad cooperative things all the time. So like, why wouldn't I expect AIs to do this? And I think AIs have a few advantages where they can both be much smarter than humans. They can also do things like self-modification, where they can modify their own source code to be easily inspectable that they will like in fact cooperate.
Like you could verify across each other and give ways of verifying that you're going to do the right thing or something like that.
Yeah, exactly. Or really what you want to do is you want to publicly have your code implement something like I will cooperate if and only if you cooperate, and then this like creates a big incentive that's visible to everyone to cooperate. So I mean, I expect to basically see things like that happen when you get really smart agents.
Nice. Well, this is good because this is one area where I hadn't thought as deeply as you have, but my initial instinct was like, oh, I'm quite scared by some of the dynamics there after we get past the first first wave of AI. So that's good. That's some optimism.
Yeah, I'm not all pessimistic.
No, and not to take it lightly, but it is good that there are some things working in our favor as well.
Yeah. All right, cool. So that was cooperative AI. I think. All right, another one is another quick research area is adversarial training. So, given examples of bad behavior, can we train it to not do those things? Or can we create good ways of coming up with examples of things we don't want the AI to do, so that we can train it on those not to do those things? And I think Redwood did a big project on that where they tried to make language models not output text in which someone got hurt, and do this with really, really high accuracy.
Yep. And that stuff's interesting because it is actually similar to what we said around things like interpretability and evaluations, where what you train against can also be, what would be like interpretability or evaluation data sets. But you can't use all of your holdouts. You've got to keep some of them for evaluation purposes, but the actual data sets you train against potentially look quite similar to what you would have developed in the course of evaluations for interpretability.
Awesome. Okay, so going down the list, truthful AI is another one where basically, can we train AI systems that are optimally truthful? And there are a variety of techniques in here. I'm not super familiar with this literature, but I think Owen Cotton Barrett and a few others wrote a good paper here, and it's related to various anti-deception measures as well as stuff like the honesty probes, I think.
Yep.
Cool. And then I think last one is brain-machine interfaces. So yeah, I'll let Sarush. I think you mentioned you had some knowledge on this one.
Yeah, look, the only reason I have some knowledge here is I've followed the Neuralink quite closely over the years, and I have a good friend who works there. Look, so essentially, when we talk about alignment, there is often the challenge of where are we humans relative to these AI in terms of our capabilities, in terms of our understanding of the world, in terms of our ability to look inside, look at these systems and make sense of them. And one very important property or one important aspect is, well, just how capable are humans? How intelligent are we? And so one area where people have invested in when they've thought about the risks around AI safety as well, can we also just make humans more capable? Now, brain-machine interfaces aren't the only one. Another thing you can do is things like use tools to make humans better, and there are other research agendas that look at like giving humans particular tools, and we kind of touched on some of them in the Scalable oversight section. But a brain-machine interface would actually just be something like inserting a chip like a Neuralink in the brain, where we just become more capable, more able to process more information or have our preferences acted out in the world. And we're already starting to do this through things like technology, like computers and laptops and phones. But Neuralink or other more advanced systems would just continue to augment our intelligence in really powerful ways. So I only touch on this, and there's obviously lots of things we haven't touched on within the world of alignment, but this is a technical solution to increasing human skills and therefore making us more capable of solving problems around AI safety.
Yeah, I think that was a pretty good list. I don't think it was everything. I think it's impossible to make a list of literally everything, and so if we didn't mention the thing you specifically are working on or something, sorry about that. Yep. But yeah, I feel pretty happy with that. Yeah.
Look, it's not easy to cover everything in any field, even one as relatively new as this one. And of course, in the world of machine learning, there's a huge amount of research out there. I think it's fantastic for our listeners that they've gotten a good coverage. I think one last thing we should definitely touch on is, how, in your view, Thomas, like how much room is there for more research agendas? So is it the case that, people have spent a long time brainstorming agendas and we've got most of the ones we're going to need to solve the problem? Or do you think there's a lot of gaps in that ecosystem of potential agendas that we should be pursuing?
I think there's a lot of gaps. So as I currently see it, I think that the field is probably not on track to successfully solving the alignment problem in time. And it would be great if we had basically new people come up with clever new agendas for how to make progress here. I think I'm also excited about people, adding on and working within some of the existing agendas. And I think I want to specifically highlight, I think, working on new model evaluations that haven't been done yet. Model evaluations like testing an AI's ability to do AI research and recursively self-improve, as well as like situational awareness benchmarks. Both seem like huge things that I would love to be done, but have not yet been done as far as I can tell. As well as, obviously the dream is, you come up with a new paradigm that just totally solves alignment.
That'd be awesome.
Yeah. So,
yeah.
for
if anyone in the audience holding out on some great, alternatives to deep learning with beautiful safety properties, please show your work.
Yeah. I'd settle for even a way to make deep learning safe,
yeah, anything. Yeah. Yeah. Fantastic. Yeah, no, I think that's right. I mean, I think when I was first delving into this world of AI safety, one of the things I personally felt was, we've come up with some frameworks for thinking about this stuff and come up with a lot of really interesting and powerful agendas with a lot of hard work. But it definitely, it doesn't feel like, say, the way we understand physics or something, where you go, okay, we've really exhausted this. Like, this covers like all the atoms of the universe sort of level of understanding. No, it's like there's a lot of ways to slice and dice these algorithms that we have today, as well as intelligence. And there's almost certainly, I mean, not even almost certainly, there certainly is a lot of gaps in our understanding of how to solve this problem. So yeah, so definitely jump in and work with agendas to get started, or if one resonates with you, but also plenty more space for new ideas that will help us better understand this problem and solve it.
Yeah.
Is there anything else you really want to talk about, Thomas? Maybe things that you would kind of suggest to our listeners as far as actions or next steps, or anything else that you really want to cover before we start to wrap up?
Main thing I would urge people to do is, I think for yourself about what is happening with AI and sort of come to your own conclusions here. And I think the evidence for alignment potentially being difficult is pretty compelling. I think the evidence for potentially AGI fairly soon is pretty compelling, and it's compelling enough to warrant, people at least spending some time thinking about, how far away do I think AGI is? Do I think we have, good alignment solutions? Do I think, where do I see the world is going? I think this is a really important issue, and I just really would love more, smart minds coming in and helping us figure out all these really difficult questions. Because I think, we just as a field have not yet figured out a lot of basic things about, how the future might go. And we're not really prepared for a lot of different situations that, very well might come up.
I completely agree. And if people are maybe not quite ready to jump in as full-time researchers, are there other ways they can help, messages they can amplify, or any other actions they can take?
Yeah, totally. So an obvious one that you can do is just, I think, help messaging and help communicate this issue to people or just on the internet. I think better communication and more sort of well thought out, thorough reasoning on this, or just pieces of writing or anything, is just really helpful to keep the conversation going in a way that's careful and is truth seeking and whatnot. So if you're able, if you think that you have a good enough understanding, or at least you can communicate what you've understood so far, I think this is just a really good thing to do. Another thing would be monetary donations. I think there's a lot of increased effort working on this issue, but there hasn't been a corresponding increase in funding, which has meant that the field has ended up being really funding constrained, and so
also maybe disproportionately amplifying voices that there are commercial incentives for, like the more capability side of things. So the safety side and other lesser voices might be being drowned out.
That's right. Yeah. So funding for, technical research organizations whose work you're excited about, or donation to policy efforts that you're excited about, I think can be hugely valuable.
Yeah. Any couple of organizations to call out in your view that are doing good work?
Yeah, from my perspective, I'm a fan of my own organization, the Center for AI Policy, and think that we're doing quite impactful advocacy work in DC, directly trying to help with this issue. Another biased one, I am a part-time fund manager for the Long-Term Future Fund. And I think we give out quite good grants for AI safety researchers. A lot of what we fund is independent researchers who are, able to just full-time think about this issue without any academic incentives or capabilities incentives attached, which I think is a valuable part of the ecosystem.
Definitely. And I know a lot of really high quality researchers myself who have been funded by LTFF. So, and not myself included. So I have no conflict of interest there. So yeah, I think there's a lot of concrete good work I've seen come out of LTFF's funding.
Yeah. And I guess maybe just for completeness, to have one where I'm not a conflict of interest, I think I want to recommend. Let's see. Actually, I want to recommend. I think Redwood Research. I don't know if they're actually taking donations, but I think they have done really good work on a bunch of things on a really minimal staff, and I just continue to see quite good work coming out of them, and really respect the people there. So I'm excited about them getting funded, though I don't know if they're particularly funding constrained right now.
Yep. Fantastic. Always great to hear from people who are working on this full time and trying to make things go better. So thank you for all those suggestions and recommendations. I think we'll pause there. Thomas, thank you so much for giving us a gargantuan amount of your knowledge, time. And it's not just your time on this podcast, it's the time, I think you said something like 80 plus hours, something like that back in the day to put together your first overview of this field, and probably more to kind of update it and prepare for this interview. So thank you so much. And I think we'll have many listeners who will take that and hopefully do great things in both research and other areas of impact towards AI safety. So thank you for your time today. Yeah,
thank you so much for having me. Really appreciate the opportunity to come on here.
Awesome. Thank you so much, Thomas, and thank you to our listeners. And we'll continue with episodes on how we best respond to the kind of the future possibilities of advanced AI systems, and keep bringing some great guests who can help us figure that out. Thank you, everyone.